Hello, students. Welcome back to class. Today we will be looking at superposition principles. Now, remember that we said if we have two charge bodies, let's say we have Q1 and Q2, separated by a distance r, the force of attraction or repulsion between them will be F is equals to K times Q1 Q2 over r squared, where K is the Coulomb constant, the constant of proportionality. And remember we said for air, K is equal to, for air or vacuum, 9 times 10 raised to power 9 Newton meter square per Coulomb square. I don't know if you can still remember that. So today, we want to look at another case. Now this is Coulomb's law. We use it if we want to solve forces between two charged bodies. This force can either be attraction or repulsion. It is attraction if both charges are unlike, and repulsion if both of them are like charges. Now, what about if we now have something of this nature? Let's say we have Q1, Q2, and Q3. How are we now going to solve for the forces between them? That's what we want to look at today. Now, let's look at this case now, the case of three charged bodies. Now, assuming we have a charge here, we call it Q1. Then we have another charge, we call it Q2. Then we have another charge, positive, we call it Q3. And in this question, they're not going to ask you to calculate the forces between these three charge bodies. No. We do ask the question because to solve for these forces between these three charge bodies, we are going to come from a principle called superposition principles. And what is superposition principle? The principle states that the force experienced by a charge due to other charges is the vector sum of the Coulomb forces acting on that particular charge due to the other charges around. So if they want to ask you any question here now, they'll ask you what is the force either on Q1, or they will ask you what is the force on Q2, or they will ask you what is the force on Q3. Any of those three questions is possible. So they ask you what is the force on a particular charge inside this place. That's how they are going to ask the question. Now let's assume we want to ask the force on this Q2. We will ask the force on Q2. How do we calculate such force? Look how to do it. They are asking us for the force on Q2. Then you mark it out. Then you will check which other charge is around. We have Q1, we also have Q3. To go get the force on Q2 now, the first thing you're going to do, you will calculate the force between Q2 and Q1. Then you keep it. You can call it F1. Then you come again. Then you calculate the force between Q2 and Q3. Then you can call that F2. At the end of the day, you will add the two together vectorially. That means you will take regard to the magnitude of the force and the direction of that same force. That is how it is done. So for example, now look at what I'm trying to say. Now, the force between this Q1 and Q2 first. Let's look at this now. Now, we are looking at what is the force on Q2. That is, Q2 is the charge moving in this place. Other charges are not moving. They are static. They are in one place. So what I'm trying to say now is, between this now, Q1 and Q2, will Q1 act an attractive force to Q2 or a repulsive force. The force on Q2 now coming from Q1, will it be a force of attraction? Attraction means if a charge is here now, let's say plus, another one is here, let's say plus. Let's say we have Q1, let's say we have Q2. And they said, what is the force on Q2 coming from this Q1? What is the force on this Q2 that is coming from Q1? Now, if both of them are having the same sign, the force will be repulsion. Now, what's the meaning of repulsion? Repulsion means it will be pushing the charge away. That is the meaning of repulsion. That means this Q1 will try to pull this one away. We repel it, means it will push it away from itself. Then if I have something like this again, let's say I have something like this. Let's say I have something like this. Let's say I have something like this plus. Then I have another one minus. Let's say I have Q1 and I have Q2. And they're asking us, what is the force on this Q2 coming from this Q1? Then if we check, if they are not the same in sign, if they are the same in sign, they will repel. The thing will repel. If they are not the same in sign, they will attract. So since we are looking for the force on Q2 now, this Q1 will definitely attract. Attract means it will bring this Q2 closer to itself. That is the meaning of attract. So this Q2 will be coming closer to Q1 because it's attracting it. Attracting it means bring it closer to yourself. Bring it to yourself. That is attracting. Repulsing means push it away from yourself. That is repelling it. So please take note of that. It's very, very important. So if we look at these two now, these two guys here, this is the one moving because that is the one in question. That is the one that will either move to Q1 or move away from Q1 or move to Q3, move away from Q3. So to look at this Q1 and Q2 now, this Q1 is going to attract or bring Q2 closer to itself. Why? Because Q1 is positive and Q2 is negative. They are unlike charges. They are not the same in sign. So they are not going to repel, they are going to attract. So this Q1 will be attracting this Q2. So you can call this one F1. Then you come again. Okay, let me remove this. Remember, this will be attracting this. You can call this one F1. Then you come to this side again. You come to this side again. Between this Q2 and Q3 now. You are going to do it between Q2 and all the charges around it. Let's do between Q2 and Q3 now. You come. Okay, will Q3 be attracting this Q2 as well or be pushing it away? This Q3 will also be attracting it to itself. So it's also dragging it because Q2 and Q3 are both unlike charges. So what you're not going to do now, this Q3 will still be dragging this Q2 to itself. So we're going to have our second force here, which is F2. Now F2 is coming from Q3, F1 is coming from Q2. So how do we now calculate the total force, which is the net force on Q2 now? How do you calculate the net? Net means the total. To calculate the net, you will add this to this using vector addition. Using what? Vector addition. Now, if you use vector addition, you will discover that anyone pointing to the left-hand side, if the force will take negative sign. Then any force pointing to the right-hand side will take positive sign. That's what you're going to discover. Whether you're doing restitution of forces or the rest, that's what you're going to get. So any force coming to the right-hand side, left-hand side, going towards the left will be negative. So Q1, this F1 is going toward the left, if you can see it. So that F1 will be negative. So we're going to have negative F1. Then F2 is pointing towards the right-hand side. So that will be positive. Positive F2. So that will be the final answer you are going to get. Assuming both of them, we are going to the right. Say F1, F2. The final force will become positive F1, positive F2. That is plus F1 plus F2. That's what we're going to have. If both of them are coming to the left-hand side, negative F1, negative F2. Now, let's look at a typical question so that you understand what I'm trying to explain. Now, considering the diagram below, Consider the diagram below. Look at the diagram. So we have plus 1 microcoulomb. Then the other one minus 2 microcoulomb. Plus 3 microcoulomb. That's the diagram. And the distance between this and this, remember, before we can get forces between two charge bodies, we must know distance is 1 cm. The distance between this and this is also 1 cm. So take note of that. So remember this. If we have two charges, let's say Q1, Q2. I say, what's the force between this Q1 and Q2? If you know their distance, arrow, we call the distance arrow, that force will be equal to K times the first one and the second one divided by the distance squared. But remember something from Coulomb's law. He said the force of attraction or repulsion is directly proportional to the product of their magnitude. That means you're going to take the magnitude of these two charges. Just take the magnitude, means do away with the sign and take away the value, and inversely proportional to the square of their distance apart. So take note of this. It's very, very important. So from that law now, we can use superposition principle to analyze from this diagram below. Now the question is, calculate the force on Q on the minus 2 microcoulomb. So remember, this one is plus, this one is negative, you can see it. This one is also positive. So the question is to calculate the force on the minus 2 microcoulomb. That is the question. So to do this now, the first thing is to locate this minus 2 microcoulomb. If we call this one Q1, we call this one Q2, call this other one Q3. We will definitely try to locate this. If you want to get that now, look at it here. It's here, look at it. That is minus 2 microcoulomb. So we are calculating the force on this particular charge here. That is the charge in question. So the next thing now is to calculate the force between this minus 2 and the charges around. Then add the forces together. So let's go. So the first thing we are going to do now, first we're going to calculate the force between this guy here. Can you see those two charges there? We calculate the force between them. So this Q2 is the one in question. So you'll be the one to either move to this Q1 or move away from it. It's called that this Q1 now is going to be attracting this because they are both unlike charges. So Q1 will be attracting this to itself. So we are going to call this one F1. The same thing between Q2 and Q3 now. You discover that this Q3 will also be attracting it to itself. So that is, we can call this one F2. Now to get the total force now, which is the F net or F total. Okay, let me just call it F net. Okay, the F net, it will be equal to anyone going to the left, negative, anyone going to the right, positive. F1 is going to the left, that is minus F1. Then F2 is going to the right, plus F2. This one is simple enough. So it's very, very simple. So let's look at the magnitude of these two forces now. How to calculate their magnitude. To calculate those two forces, we'll need those two forces before we can get the final answer. So for F1 is the force between these two charge bodies here. Between these two. That is F1. So we're going to have K, Q1, Q2 over their distance squared. That is all. So that's what we are going to need here. So F1 will be equal to K, Q1, Q2 over the arrow squared. Over the arrow squared. So how are we going to do that? Look at, let me show you something now. Just take note. For Q1 is equals to 1 microcoulomb. And this micro means, that micro means 10 raised to the power minus 6 in physics. That is meaning of that micro there. And that thing that looks like U, it means 10 raised to the power minus 6. So that this means 1, then remove this micro, then replace it with this means 1, then you remove this one, replace it with 10 raised to the power minus 6, because that is the value for that thing that look like U. Then this C will remain. So we have 1 times 10 raised to the power minus 6 Coulomb. That's how to convert that. If you also want to convert this, you remove this one, put 10 raised to the power minus 6 there. It will be 2 times 10 raised to the power minus 6. If you also want to convert this, remove this, put 10 raised to the power minus 6, because that is the value for that micro. Then, if you want to put the charges in this place, or to put these charges here, don't add either plus or minus to them. Why? Because we are looking for the magnitude of the charges. That's what we are using in this place. Take note of that as well. Those are the two things you're going to take note of now. Then, if you want to convert from centimeters to meters, you divide by 100. That's how to convert. For example, at this distance, you want to convert 1 cm to meters, because it must be in meters. Then we are going to divide that one by 100. That will give us 0.01. That's what we're going to have. 1 divided by 100 is 0.01. So please take note of that. It's very, 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 very important. So our F1 now will be K, Q1, Q2 over R squared. So that will be, what is K? K is 9 times 10 raised to the power 9 for air. Then equal, that is times, not equal to 9 times 10 raised to the power 9 times Q1. Q1 is this, look at Q1 here, which is plus 1 microcoulomb. So remember I told you we will not add plus to it. So it just be 1. Micro means 10 raised to the power minus 6 times, then Q2. Q2 is this. Well, we are looking for the force between Q1 and this Q2. So remember I told you Q2 is minus 2 microcoulomb. Remember I told you this minus will not go with it. So we just take the 2. Micro means 10 raised to the power minus 6. Then divided by the distance between this Q1 and this Q1 and Q2. What is the difference between them? The distance is 1 cm. And 1 cm is same thing as what? 1 over 100 in meters. If you want to convert it to meters, divide it by, if you want to convert something to meters, from cm to meters, from centimeters to meters, you divide by 100. That is all. So if you divide by 1 by 100 now, you are going to have 0.01. Then you square it from this one. It's already, this one is squared. So from there now, you use your calculator to solve this. 9 times 10 raised to the power 9 times 1 times 10 raised to the power minus 6 times 2 times 10 raised to the power minus 6 divided by 0.01. So what I'm going to have? The answer is going to be 180 newtons. That's going to be the F1 we're having there. So keep this answer. Our F1 is 180. So keep that. So let's go and calculate for F2. Let's go and calculate for F2 now. So please keep the answer. Very, very important. Remember our F1 is 180 newtons. So the F2 will becomes the force between these two guys here. Got it? The force between these two guys. Q2 and Q3. So we have K, Q2, Q3 over R squared. So that will be equal to K is 9 times 10 raised to the power 9 times Q2 is, remember I told you the sign will not go with it. Q2 is 2 times 10 raised to the power minus 6 for microcoulomb. Then Q3 is 3 times 10 raised to the power minus 6 for microcoulomb. Then divided by the distance between these two. What is the distance between this and this? 1 cm, which is still divide to move it to meters, divide the 1 by 100, that'll give us 0.01. Then you square it. So if you solve that with your calculator, we are going to have 540. Please just confirm it. We're going to have 540 as your answer. So our F2 is equals to 540. So take note of that. F2 is 540. So let's go and calculate the total force now, the F net. This is the procedure for calculating the forces that exist between charge bodies more than 2. So our F2 is equals to 540 newtons. So remember we said F net, which is the total force, or F total, can be F total or F net, will be, this one is coming to the left, that is minus F1, and then we'll go to the left, this one is going to the right, plus F2. So that will be F1 is 180 plus F2 is what? 540. So that will be equal to 360 newtons. That's what we are going to have. Now let's look at more examples. All right, let's assume we have this particular question. We have these charges. We have 3 charges, 1, 2, 3, in which all the charges are positive. All the charges are positive. This first one is plus 3 microcoulomb. Second one is plus 4 microcoulomb. Then the third one is plus 5 microcoulomb. And the distance between them as follows. The distance between them as follows. The distance between these 2 charges here. The distance between these 2 charges here. This and this. Let's say this distance is 2 millimeters. 2 millimeters. Then this is 3 millimeters. So let's go for this to see what we are going to have now. Remember, micro means 10 raised to the power minus 6. Remember that. And to convert this distance now, so the question, let's first look at the question. The question is to calculate the force on on which of the charges on the plus 5 microcoulomb. That's the question. To calculate the force on the what? On the plus 5 microcoulomb. So it's still the same procedure. It's still what? The same procedure. I told you guys before, just mark out this charge in question, plus 5 microcoulomb. That's the charge in question. And the first thing, I will calculate the force between these two, 5 and 4. Then we'll keep the answer. We'll calculate the force between these 3 and 5. Between 3 and 5. Then we also keep the answer. So we're going to do this and this, this and this. So please take note of that. It's very, very important. So let's go. Now let's also go with between 4 and 5 now. Between 4 and 5, between these two. What kind of force is this plus 4 going to exert on plus 5? It will be a force of what? Repulsion, because both of them are positive. So this plus 4 will try to push this plus 5 away. So this 5 will be running away from this 4, since they are both positive charges. So I'm going to call that one F1. Then again, we'll come back. What kind of force is this stuff here, this plus 3, going to exert on this plus 5? What kind of force? Check. This is positive. This is positive. This is also positive. Both of them are positive. So this plus 5 will also be running from this plus 3. So plus 3 will be pushing this plus 5 as well. So plus 3 will also be pushing the plus 5 away. So we can call that one F2. You can call this first, you can call this one F1 and call this one F2, no problem. So far you know what you are doing. But the one coming from 4 microcoulomb, I'm calling it F1. The one coming from plus 3 microcoulomb, I'm calling it F2. You can call the one coming from plus 3 F1, call the one coming from plus 4 F2. But ensure you know what you are doing. At the end of the day, if you want to calculate the F1, it will be between 3 and 5. If you want to calculate the F2 between 4 and 5. But for this case now, the one coming from this 4, I'm calling it F1. So if I want to calculate F1 now, it will be between what? 4 and 5. So that will be K. You can also call this one Q1, Q2, Q3, but I don't want to label it now. So I'll just call this one K, Q4, and Q5. Q4 is the 4 microcoulomb, Q5 is the 5 microcoulomb, divided by the distance between 4 and 5 squared. So that gives us, what is K? 9 times 10 raised to the power 9 times, what is Q4? That is the charge for plus 4 microcoulomb. That is 4. Remember, we don't use the sign. 10 raised to the power minus 6. 10 raised to the power minus 6 is for micro. Times Q5 is the charge for plus 5 microcoulomb. 5 times 10 raised to the power what? Minus 6. Then divided by, what is on between 4 and 5? The distance is 3 millimeters. To move 3 millimeters to meters, you divide the 3 by 1000. So if you want to move from millimeters to meters, you divide by 1000. So divided by 1000. Okay? Sorry about that. Divide this by 1000, I'm going to have 0.003. Then you square it. So the final answer is going to be, if you solve this very well now, you are going to have a very lovely answer. And that is going to be 20,000 newtons. That's what you are going to have there. So now, go and solve. Pause this video now. We have I've successfully calculated for F1, which is between 4 and 5. I don't know the one you want to make your F1. You can make between 1 and 5 your F1, 4 and 5 F2, no problem. So I've calculated between 4 and 5 now. Now you go and calculate the force between 3 and 5 and tell me the answer. Pause this video, calculate the force between 3 microcoulomb and 5 microcoulomb and tell us the answer. So remember the distance and so on. So just pause video now and quickly do that. So now, to calculate the force between 3 and 5, you just see the same way. But just one little things we are just going to do. So we are going to do Q3. We are going to do 3 microcoulomb now, and the 5 microcoulomb. That's what to do now for 3 and for 5. So we are going to call that one F2. F2. Remember, this one is 3 millimeters. This one is 2 millimeters. So that at the end of the day, we are going to have Q for 3 microcoulomb and the Q for 5 microcoulomb divided by their distance squared. That is 9 times 10 raised to the power 9 times. Now what is Q? That is for 3 microcoulomb, this first one here. So we're going to have 3 times 10 raised to the power minus 6 times, then the Q5, this one for 5 microcoulomb, that is 5 times 10 raised to the power minus 6. See, this Q3 means 3 microcoulomb charge, Q5 means 5 microcoulomb charge. I'm not using Q1, Q2, Q3 this time. Then you can use any one you like, so far you understand what you are doing. Like just that, also just labeling. Just know that if I say calculate the force on this Q, like this calculate force on Q5 now, you do between 5 and 4, do between 5 and 3 again. That is just one thing you should note. We are still going to do some examples more. Then divided by, what is on between 5 and 3? What is on between this and this? Check. That is from here to here. This distance here. So what is that distance? It means when you add these two from here to here plus from here to here. So the distance between 5 and 3 now is 2 plus 3. This plus this. That will be the distance between 5 and 3. Check it very well now. From between here to this place. What distance are you going to cover? You're going to cover 2 millimeters and 3 millimeters. That is 5 millimeters. So the distance is 5 millimeters. The distance is 5 millimeters. So to move 5 millimeters now to meters, to move 5 millimeters, to meters now, divide by 1000. Divided by 1000. Then we're going to have 0 0.005, and you square it. You do what? You square it. So that will give us a very nice answer. And the answer will be 5,400 newtons. 5,400 newtons. So if you check very well now, what will be the total of these two forces, which is the F net? What is the total now? F net will be equal to, check, Q1 is going toward this side. Q3 is also pushing this one toward this side. Remember, Q3 push this Q5 away from itself. Pushing means it will push it to the, check, how do you push something? If Q3 want to push Q5 now, where will you push it to? Push means to repel it away from you or take it away. That's just something like I don't know how you will understand that. For example, now let's say you are pushing something. Where do you push something to? Do you push something to yourself or push it away from yourself? If I say push it, you push it something like distance it away from you. If I say pull it, you pull it away to you, pull it to yourself. Pull is attraction, pushes, you repel it. So this plus 3 will be pushing this 5 away, and this plus 4 will also be pushing the 5 away. You see, both of them is pushing the plus 5 to the right. You can see it. So F1 is going to the right, F2 is also going to the right. So the final answer will become plus F1, since it's going to the right. Remember, anyone go to the right is plus F2, since one is also going to the right. So that will be equal to, what was F1 again? F1 was between 4 and 5, and that was 20,000. That was 20,000 plus F2. You want just calculated 5,400. So that will give us, that will be equal to 25,400. 25,400 newtons. So this is the total force on Q5. So take note, these forces can be either negative or positive. Why? Because they have two nature, either attraction or repulsion, depending on the place the thing is attracted to or repelling to. So they are repelling this one out to the right hand side. For example, now assuming I said, what is the force on this Q3? You can go and try that. Let me say, what is the force on this Q3 now? You discover that this plus 4 will be repelling the Q3 to the left. Plus 5 will also be repelling the Q3 to the left. So the answer you are now going to have will become negative at the end of the day. You do 4 and 3, 5 and 3. But both of them will push the 3 to the left hand side. You can see it. So that's how these things work. So let's look at another question. Okay, now let's assume we have a charge here, positive. Let's call it positive 6 microcoulomb. Then another charge here, negative, let's say negative 7 microcoulomb. And the third one here, negative as well, negative 8 microcoulomb. So this we have positive 6, negative 7, negative 8. Negative 8 means minus 8. So the distance between them, let's assume they have equal distance apart. So let's assume this is 2 cm. This is also 2 cm. The line of action of their forces. The line of actions of their forces. Let's say the question now is to calculate the force between calculate the force on the plus 6 microcoulomb. Let's say calculate the force on plus 6 microcoulomb. So that's the question. Calculate the force on this plus 6 microcoulomb. So how are we going to do that? So I would have loved if you can pause this video now, then quickly calculate that force to see if you can get the answer. Calculate the force on this plus 6 microcoulomb now. So I would love you to drop this video, just pause it first, you go and solve it out, then come back and continue to see if you're able to get the answer, because that is the best way to learn. So remember, first you mark out the charge, which is the plus 6. The next you check, we have minus 7 and 8. So if you ever solve between plus 6 and this minus 7, you keep it. Then you come again, you solve between plus 6 and 8, then you keep it, then you find the total later. Remember, anyone go to the left will be negative, anyone go to the right will be positive. That's just a short way to resolve the final answer. So between 6 is the one moving, 6 plus 6 is the one moving, either repelling or attracting. Others are not moving. They are the one either pulling the 6 or pushing that 6. And other charges are the one pulling the charge in question, whether pushing it or pulling it. So let's check for this first one, which is 7. Minus 7. Will minus 7 attract plus 6 or repel it? It's not going to push it because both of them are unlike charges. So this minus 7 is going to attract plus 6 to itself. So plus 6 is going to be attracted to minus 7. So let's call that one F1. Then for this minus 8, is it also going to attract this plus 6 or repel it? Attract means it will pull it to itself. Repel means it will push it away. So minus 8 will also be attracting plus 6 to itself. So that's F2. Why will minus 8 be attracting plus 6? Because both of them are still unlike charges. Now to calculate F1 now, I'm going to use formula Q. Okay, let's say Q6. That's Q for 6 microcoulomb. Then Q7 for 7 microcoulomb. Although that 7 is negative. Although we don't take regards to the 7. So let's just use 6 and 7. We don't take regard to the negative sign when we are calculating this. The signs will only tell us whether they are attracting or repelling. That's what the sign does in this place. They're divided by their distance squared. So that will be equal to, K is 9 times 10 to the power 9 times 6 microcoulomb. Remember, we don't use signs here. Minus 6. That's micro means 10 to the power minus 6. Then 7. Remember, we'll do away with this sign and use only 7. 7 times 10 to the power minus 6. Then divided by the distance between 6 and minus 7. Now, what is the distance between 6 and minus 7? The distance is 2 cm. To convert to meter, divided by 100. That's 0.02. Then you square it. So if you do that very well, you are going to have a very lovely answer, 945 newtons. That's what you're going to have, 945 newtons. The next, you keep this answer, keep that. That is for between 6 and minus 7. So let's do between 6 and minus 8 now to check what we are going to have. Remember, this is 945 newton for this first one we just did. So this is 945 newton. So let's go for F2, which is between 6 now, between 6 and 8. So I'm going to use 6 and 8 now. Q for 6, then Q for minus 8. Then divided by their distance squared. That will be equal to K is 9 times 10 to the power 9 times 6 times 10 to the power minus 6 for microcoulomb. Then times 8. Remember, this minus will not take regards to it. We'll just use the 8 times 10 to the power minus 6 divided by the distance between 8 and 6. So what is the distance between this 8 and this 8 and this 6 is from here to this place, full distance, which is this 2 plus this 2 again. That is 4 cm. So divided by 100, that is 0.04. Then you square it. So that is going to give us a lovely answer, which is equal to 270. It's equal to 270 newtons. So to get the F net, to get the total force now, we're going to apply that resolution of forces. So remember, check. If you check very well, let me delete something so that you will. So remember, this F2 is Q is 270. So try and remember that is very, 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 very extremely important. So let's look at the F net now. If you have been following up with this video, you'll be able to calculate the F net here. You'll be able to calculate the F net without any. Remember, this one is 8. Remember, this 8 is still attracting this 6. So check where are both of them going to. So the F net will becomes F for F1. F1 is going to the what? Check is going to the right. That is plus F1. F2 is also going to the right plus F2. Simple as ABCD. So that'll give us F1 is 945 plus F2 is 270. So that will give us 1,215. It was 1,200 what? 215 newtons. So that's what we are going to have. 1215. So last question. Let's call this last question. So take note, this is the final answer here. So just know how to calculate this F net. Just check where they are going to for this linear arrangement of charges, whether they are even 4 or 100. Anyone go to the right, positive. For example, assuming we're having a negative charge here now, this negative charge will be pushing this will also be attracting this plus 6 to itself. It will now be 3 and 4 6. They are still going towards the right hand side. All of them will still be positive. So just take note of that and just know what you are doing. That is all. So let's look at the last question. Now, lastly, let's assume we're having this arrangement: minus, negative, negative. We have 3 negative charges. Then let's check for the distance between them. The distance between them is that this is 5 millimeters. Okay, let me write it this way. Because is 5 millimeters. This is 8 millimeters. After writing this, you just go and try to see if you will be able to get the answer. That is the major thing there. Then this is minus 1. This is negative 1. This is negative 2. This is negative 3. They are all in microcoulombs. So the question now is, for you to go and calculate the force on this minus 2 microcoulomb. That's the question. Calculate the force on the minus 2 microcoulomb. What is the force on the minus 2 microcoulomb? So that's the question. So you can pause this video now, quickly calculate that force to see if you're able to get the answer. That is all. So to do that, the first thing, consider minus 2 and minus 1. These two first. So will this minus 1 attract minus 2 or repel it? Attract means it will bring it closer to itself. Repel means it will push it away from itself. Take note too. So will minus 1 attract minus 2 or repel it? Truly speaking, or frankly speaking, minus 1 cannot attract minus 2. Minus 1 will always repel minus 2. So minus 2 will be running away from minus 1. So that will be our F1. So remember, this is the force between this charge and this charge. Take note of that. It's very, very important. Then again, minus 3 between this and this. Now, minus 3, will it be attracting minus 2 or it will repel it? Minus 3 will also be pushing the 2 away. That will be our F2. So please take note of that. It's very, very, very important. So just take note that -2 cannot attract -3, it will push it towards this side. So this -3 will be pushing the -2 towards this side. That will be our F2. To take note of that, that will be our F2. So the next thing now will be to calculate the F1 and F2. So our F1 now will be Q1, that's Q for 1 microcoulomb, then Q for 2 microcoulomb divided by R squared. That is, our K is 9 times 10 raised to the power 9 times 1 microcoulomb, that is 10 raised to the power -6, times 2 microcoulomb, 10 raised to the power -6. Remember, we don't use signs here. We only use times to check whether they will attract or repel. Divided by, what is the sum between 1 and 2? The sum between 1 and 2 is what? The sum between this 1 and 2. So what is that distance? The distance is 5 millimeters. 5 millimeters squared to meter divided by 1000. That is 0.005. Then you square it. So this will give us, to solve this very well, that is going to amount to a very lovely answer, 720 newtons. 720 newtons. That is what we are going to get. So just keep that. Now let's go and do for F2. Let's go and calculate for F2. F2. So our F2 now will be equal to Q for 2 microcoulomb and Q for 3 microcoulomb divided by the distance squared. That will give us 9 times 10 raised to the power 9 times 2 times 10 raised to the power -6 times 3 times 10 raised to the power -6 divided by, what is the sum between 2 and 3? Sum between these 2 and these 3. What is that distance? That distance is 8 millimeters. To convert millimeter divided by 1000. That is 0.008. Then you square it. So that will give us, if you solve that very well, you're going to have 843.75. So you're going to have 843.75 newtons. Now to get the F net which is the total force, will be, anyone go to the left, Q2 is going to the left, that's negative Q2, then anyone go to the right, positive Q1. So that will be equal to minus 843.75 plus 7, remember the first one is 720 for F1. So this will be equal to, if you solve that very well, we're going to have minus 123.75 newtons. That is what you are going to have as your answer. So the answer is negative. That means the total force is pushing this particular charge to the left hand side. If the final answer is positive, it means the total charge is the total force is pushing the charge to the what's it called, to the right hand side. That is just all. So this is just a procedure we follow if you want to solve this type of problems. Now in case of exam condition, you can just use shortcut to do everything to ensure that you get the answer. So if you want to just use shortcut, you can just take your calculator. Remember, you can type this one into your Casio calculator. And if you can still remember that, you can type that to your Casio calculator. So, for example, if you want to solve this particular problem in exam, okay, let me just show you how to do that. Just show you how to quickly do that. Let me show you how to do that so that you understand that aspect very, very well. So it's not actually that hard. It's just for you to get the concept. You can get the concept. You can even solve without writing anything down. You can get this concept. You can solve without writing anything down. So the first thing is to analyze it this way. to know where the forces are going to. Then the next, we just say the net force will be, which one is going to the left? Minus. That's minus F1. F2. What's F2 between these two? That's F2. That's our F2. So you just come minus K is 9. Okay. Let me just use K. Q for 2 microcoulomb. Q for 3 microcoulomb over their distance squared. Then we'll go to the right positive plus K. What's okay for F1 is between this and this. You just type our Q for 1, Q for 2 divided by their distance squared. So you just type this into your calculator directly. Minus 9 times 3 to the power 9 times 2 exponential minus 6 times 3 exponential minus 6 divided by the distance, which is 8 millimeters, 0.008 squared. Then plus K, just 9 times exponential 9, then 1 exponential minus 6, then 2 exponential minus 6 divided by 0.05 squared. You just press equal to, just give you the answer directly. Just try and see if you can type this into your calculator now by putting their respective values to see if you get the answer I'm actually trying to say. Thank you. God bless you.